Hi and welcome to the brand new episode of the 3D Printing Bunker with Bearded Thinker. Today we are not going to have only printing, but we also have some soldering and fixing things up. So stick around and we'll start in 10 seconds. So what I did today is not today, but what I did for the last couple of weeks. First of all, I've been collecting a lot of equipment and material. For example, let me show you what I did. Okay, so I got those smaller banana sockets, larger banana sockets, some switches, potentiometers, volt and amp meter, and step up, step down converter, buck converter. What I also did, I got myself an old power supply. It's here. This is the old power supply I found in one PC. Sorry that I took it out. And what I also did is I did a lot of printing. This is about 20, 25, 30 hours worth of printing. Not everything was printed correctly. As you can see, part of the print detached itself. And also, as you can see, there are two types of filament. Here, this one is different than this one, but that's no issue. For what I needed, this is perfect. Don't worry, I will be posting all the links and information about components down in the description. I will also post a couple of links for videos and posts that inspired me to do so. And I will also be posting this. This is something I designed based off something else, but this is really my design. I wanted to have this layout, so I played around a bit with various available STL files or designs on Thingiverse, and finally I created my own. So first of all, you can check here in the description what my primary inspiration for this project is, and a lot of the things that are here are based on the design on the link I will be posting here or in the description. But unfortunately I did run into some problems related to the this component. This component is a bit different than the component provided that video. I will be also posting a link to a very nice detailed video that explains how you have to connect this one. I will turn this around a bit so you can so I can show you. It's pretty simple. What you really have to do is you have to get ATX power supply. Then you have to cut the connectors, and here you will find a couple of specific wires depending on what type of ATX power supply you have. For example, black wire is of course ground, red wire is 5 volts, orange wire is 3.3 volts, yellow wire is 12 volts, but I have two types of yellow wire. Let me just find it. So as you can see, I have yellow black and I have pure yellow. So what this means is that this power supply has two individual rails for the 12 volts. So I used one 12 volt to provide 12 volt for the standard output, and the second rail 12 volt supply to power this step up step down converter. Then what I had to do is, you will see it in the time lapse, I had to remove those potentiometers that were soldered on board and solder external potentiometers so I can put them on the faceplate here. Next thing, what you have to do for every power supply that you want to use as for example workbench power supply, you have to solder or connect the green wire and the black wire. This is what turns the power supply on. But what I found out is that my power supply also has sensor wire, let's call it like that. And this is the brown wire. And this brown wire has to be connected permanently to 3.3 volts. So in order for me to get power supply started, I had to connect this on a switch, which enables me to turn it on and off. And I also had to connect those two wires here. These wires are extra, I'm not using. Those are, for example, negative 3 volts or negative 5 volts and things like that. I will not be using it. These are extra ground, extra 3 volts, 5 volts and 12 volts. I will keep them and I will save them in here for future. For example, what I want to do and I didn't do because I didn't have connector is move everything here a little bit differently and add, for example, 1 or 2 USB connectors. So you can, for example, have 2 phones charging or 2 devices connected here at the same time. Next thing what I said is I bought this step up step down buck converter. As you can see, 12 volt from the second rail is coming on incoming plus. This is ground in minus. I removed those 2 potentiometers, put 10K potentiometers on the faceplate. And then there was some weird soldering going on. Unfortunately, there are a couple of those models. I will post a link to the one I'm using. And they are different on how you have to connect. So this red and black wire are connected directly to the 5 volts, and what this gives permanent power to the LCD screen. No matter if there is load or not, or if this switch is on or off, you will see at least 00 here. Those are 2 wires. Next, ground wire or black wire from the step up step down converter goes with this thick wire to the LCD. Red wire or positive wire goes to the, listen carefully, negative on this side. And the signal wire, this is a small yellow wire, is connected with the red wire that is connected to the switch to this buck converter out positive. So buck converter positive goes to switch. If I turn it on, the power goes here to this red socket. And the signal wire also has to be on the this socket. And the red wire or positive wire has to be on the negative from this thick wire. So yeah, it was a bit pain to find out because there are a couple of additional ways. For example, you don't have to use a permanent 5 volt or ground. You can keep the you can remove the ground and have this connected also with here, so you'll have power on when there is load on those sockets. But I like to see, and I'd like to be able to see the screen even if there is no load here. Also, as you can see, I have here a red diode, and yeah, in order to get that running, I had to, oh joy, oh happiness, as you can see, this leg broke down. Now, no matter, I have a couple of spare diodes, but what I had to do, I had to connect the black wire or negative, and here I had to add a resistor to have some kind of additional load on the LED diode so it doesn't burn out. But yeah, as you can see, it broke even before it burned out. Let's jump to the time-lapse. This is only partial time-lapse because it took me a lot of hours and I didn't record everything. And I will be seeing you in the last step. This is the putting face on this box, putting screws in, and testing the volts provided by this power supply. I'll see you in a couple of minutes. And okay, we are back. So let's first start with simple tasks. Let's turn it on. Oops. Let's turn it on. Okay. So let's check voltage here. And as you can see, 3 volts here, 3.3 volts here. It is 3 volts here, but it's really 3.3 volts here. Okay, let us check next one. 5 volts, 5 volts. 12 volts, 12 volts. And let's see this one. Zero volts, 0 volts. Okay, sorry. 1.2 volts, 1.1 volt. And we can slowly increase it. Increase it all the way up to, all the way up to 25 volts. So why I built this? Because I have my TS100 soldering iron currently working at 19 volts from this power supply. Oh, let me get it. Yeah. Strange. Okay, 19 volts. So it's let me zoom in. Okay, so it's 19 volts, 3.4 amps. And as far as I remember, 19 volts is pretty quick to heat up the soldering iron. But if I would use 24 volts, it would heat up in something like 30 seconds to whatever temperature really I need. And I'm soldering between 320 and 360 depending on the wire I'm using. After a couple of weeks of playing with it, this is what I was building. Voltmeter is, let's say, it's close enough. So this one is saying 25, this is 20.9. There is on the back side also a little screw that you can use to tune in the voltage and the amps. Unfortunately, I do not have anything else that I can connect my banana plugs to. If I would also test the amps, but yeah, I will have to do it offline and off camera. This is it. I really hope you enjoyed this video. I had fun building it. It was a little bit frustrating at times, especially with my fiddly fat fingers that break stuff. And also with my knowledge of electronics, almost at infinite zero. But nevertheless, it was really fun to troubleshoot why I couldn't get volts here, why I had here 4.28, whatever I tried to do and whatever I did. And it was, yeah, fun time printing, and yeah, not so fun at one part because I managed to print. This is not what I would prefer to have. Yeah, it's not finished nicely, but well, it's good enough, let's say it like that. But for example, I had problem with this back plate. I printed everything in one go, not in one go, but you know, printing one item after the other. Until I reached this one, it took me 3 or 4 days to print this one. No matter what I did, no matter how I tried to print, no matter what surface I put, it just didn't want to stick first layer onto the bed on the printer. So I had to scrap about 30 prints. I re-leveled bed manually, although I have ABL. I cleaned it, I changed it, I used original Ender 3, went back to the PI, but still after 3 days I think I finally managed to print it. But that's it. So yeah, it was really fun. I hope that someone will enjoy this video. I know this is not really detailed how to build it, but by looking at my video, how I trace the wires, by looking at the original post where the original author built wooden case for the power supply, and also by looking the video I will be providing you a link to, you will definitely manage to do it. If I manage to do it, anybody can do it. Thanks again for watching this video. I hope you enjoyed it. If you have any kind of a comment or a question or a wish, please leave it down below in the comment section. I will be posting the STL files for this front plate I built, and I will also be posting STL files for the other parts of the case I used from the Thingiverse. And I will be seeing you in 2 weeks in another episode of 3D Printing Bunker. Bye bye, have fun, and I'll see you next time.